In this lesson, we're going to discuss how to estimate the square roots of non-perfect squares. So what is a non-perfect square? A non-perfect square is a number that cannot be written as a product of two equal whole numbers or two equal fractions or decimals. So as an example, I can say that the number 5 is not a perfect square. So how do I know this? I know that because if I take the square root of 5 and I use a calculator to do this, just for example's sake, I will find that the square root of 5 is approximately equal to 236.0679777. This is non-terminating, so this is a non-terminating decimal. And that means that this pattern will really go on into infinity. And any number whose square root is a non-terminating decimal is a non-perfect square. I cannot write it neatly as a product of two equal fractions or decimals. It's just not going to happen. It can't happen. Let's look at an example as a fraction. So how do I know if a fraction is not a perfect square? A fraction is not a perfect square if I take its square root and again I get a non-terminating decimal. So if I take the square root of 2/3, so 2/3 is not a perfect square. So I take the square root of 2/3, I get 0.81649,658. Once again, this is non-terminating, so I can say that 2/3 is not a perfect square. Now, how can we estimate square roots of decimals? There are a couple of strategies for estimating the square roots of decimals. To do this, we can use benchmarks. So benchmarks are known quantities that we can use to estimate the square root. In this case, benchmarks would be the nearest perfect squares. Or we can use a calculator. This is not my preferred method, but it does work, and we need to also understand why it is just an estimation. So let's look at an example. So let's look at how to calculate the square root of 6.8 without a calculator using benchmarks. And benchmarks are a quantity of known comparison. And what I want to do is use the nearest perfect squares. So in this case, and bear with me with regard to my drawing skill or the lack thereof, I know that 6.8 lies between the perfect squares of 3 and 9. Or of 4 and 9, sorry. And so I know that the square root of 4 is 2. And that the square root of 9 is 3. And somewhere around here, between 6 and 7, and 6.25 is the next perfect square root. So I know that 6.8, if I take the square root, that the square root of 6.8 is right here. There's 6.8 thereabouts. So I know that the square root of 6.8 would probably be, and again if you forgive my lack of artistic skill here, would be between 2.5 and 2.5 and 3. And so a reasonable estimate for the square root of 6.8 would probably be slightly greater than 2.5. And so 2.6 is most likely a reasonable estimate. So I can do the same calculation or the same estimate using a calculator. So if I use the calculator and hit the square root button with 6.8, that will give me the number 2.60768 0.0962, and that's one of the numbers that my calculator gives me. And this again shows us that it is just an approximation. If we have a non-terminating decimal, it shows us that it is not a perfect square. And so it would be reasonable to estimate around this number to approximately 2.6. So it actually goes to show that my first estimate without a calculator was quite a valid one. And one more time before we move on to the next thing, I just want to make sure we understand what that symbol means. This means approximately equal to, or estimated. So writing with the stylus is hard. Okay, we'll go to the example. So how do we estimate a square root of a fraction? So there are several different strategies for determining the square root of a fraction, including using benchmarks, writing a fraction as a decimal and then using benchmarks. Oops, so ignore my typo there. Choosing a fraction that is easier to work with, or using the square root function on the calculator. So let's work through each of these examples. First one, estimating a fraction for the square root of 8/5. So this strategy works very well. One strategy that works for using benchmarks is to determine a fraction close by that it is easy to calculate here. So the square root of 8/5 is approximately equal to the square root of 9/4. So why did I use 9/4? Well, 9/4, the square root is very easy to calculate. So the square root of 9/4 is just equal to 3/2. So I can say that the square root of 9/4 is equal to 3/2, and therefore the square root of 8/5, I can say with reasonable certainty, is approximately equal to 3/2. Let's look at another example. Another way to estimate a square root of a fraction is to write the fraction first as a decimal and then use benchmarks. So if I'm going to convert 4/10 to a decimal, dividing by 10 just leaves that root 4/10 is equal to the square root of 0.4. And from this strategy, I want to use, if I'm using this strategy, I can now look at 0.4 and see that it is very close to the perfect square's 0.36. And then the nearest perfect square would be a little further away, which would be 0.49. So I can do a very quick visual estimate and assume that 0.4 is close to the 0.36 and it is 0.49, which it is. So if I was to estimate to the nearest tenths, I would say that the square root of 4/10 is approximately equal to 0.6, because the square root of 0.36 is 0.6. So that is a quick and easy way to estimate the square root of a fraction using, or by converting it to a decimal and then using those benchmarks. A third strategy is to convert the fraction to a fraction that is easier to work with. So for example, let's find the square root of 7/13. So the square root of 7/13, well, I can say with reasonable certainty that that fraction is very close, or could be very close, to the square root of 7/14. Why did I use 7/14 as an approximately equal to fraction? Well, 7/14 is equal to 1/2, which is equal to 0.5. I can now use benchmarks because I know 0.5 is very close to 0.49 and quite far away from 0.64. So if I was to estimate to the nearest tenth, I know that the square root of 0.49 is equal to 0.7. So I can say that the square root of 0.5 is approximately equal to 0.7. And for our last technique, we can just use a calculator. So the square root of 19 over 6, all I need to do to enter this into a calculator is do 19 divided by 6, and I hit the square root button. So 19 divided by 6 gives me, if I hit the square root button, gives me 1.799513042. I know this is an approximation because, again, I have a non-terminating decimal. So those are 4 different strategies for finding or estimating the square roots of non-perfect squares.